Here is an application about related rates, basically derivatives, on circumference of circle. A stone is dropped into a lake and waves move in circle at a speed of 5 centimeter per second. So this statement is kind of same for a couple of my questions. So you have understood this by now, right? That means there is a stone and as it drops on a quiet lake, it will send ripples, right? So I'm doing it again and again so that you get the idea. It could be a raindrop or it could be an oil spill, whatever it could be. Do you see that? But the idea is that there is a drop and which changes the world and this ripple moves. Now the speed of the ripple is given to us, and when we say speed of the ripple, we are literally saying that rate of change of radius. That helps. So it's that concept of relating that speed to radius of circles. The concentric circles, that is most important, right? So the radius is increasing. So rate given to us is actually dr dt. Change in radius with respect to time, and that is 5 centimeters per second. Okay? A stone is dropped into a lake and waves move in a circle at a speed of 5 centimeters per second. I could have written this statement as oil leaks from a tank and that's how it goes. Or a raindrop falls and that's how it goes. So it could be anything. Okay? Now, but basically it means dr dt is 5 centimeters per second. Okay? Second part. Find the rate of increase of circumference when r equals to 1, 2, 3 and so on. Explain your answer. So what is circumference? Circumference is 2 pi r. That is how circumference is related with radius. So basically we are trying to connect two things, and so we have related rates, correct? So if circumference is related to radius and there is a related rate of change of radius, there has to be a rate of change of circumference also, since both are related, and this is all about related rates. So let's find the rate of change of circumference with respect to time. How both are changing? As the size is increasing, the circumference is increasing, right? So with time, circumference is changing. Circumference is a function of time, right? But we are writing it in terms of radius. But we can always differentiate circumference and time with respect to time. So we can always differentiate circumference and radius with respect to time. So we'll get dc over dt equals to 2 pi dr dt, right? So that is what you get after this differentiation. Now the question is, find the rate of increase of circumference when r is 1, 2, 3 and so on. But rate of change is kind of constant. You see, 2 pi is constant, so r, it is not really dependent on r. So what do we get? So for all these different values of r, we get just one value. So what we get really is that rate of change of circumference is actually equals to 2 pi times dr dt, which is 5 centimeters per second for us, which is 5 centimeters per second. So we get an answer as 10 pi centimeters per second, right? So that is what we get, 10 pi centimeters per second, and it is constant whether r is equals to 1, 2, 3 or whatever, right? So what we are trying to emphasize here is that rate of change of circumference is not really dependent on radius or the size of the circle at any instance of time. It is only dependent on speed with which the wave is moving. Do you see that? Speed with which the wave moves, that is dr dt, change in radius, rate of change in radius, not with respect to radius. So that's a very, very important aspect of looking into this, correct? So since it is a linear function, you see 2 pi r is a linear function, correct? And so 2 pi, the slope, is the rate of change of circumference. When we do rate of change of area, you will find that it is same as change of circumference, which you'll note in the next example. I hope you appreciate that also. Thank you and all the best.